Yo, what's up, everybody? Welcome back. Today we are working on USB support in my Raspberry Pi Pico firmware. So context here is that I'm making an Xbox controller. Why, you might ask? Well, because, a long time ago I hurt my wrists playing too much Fortnite. I can't really play mouse and keyboard very effectively anymore without like my left wrist getting like really messed up. So I had to switch to playing video games on controller. Gross. Ew, nasty, right? But this is the world we live in. And so, I bought this controller. It's kind of nice. It's got some paddles, which are good because, when I'm playing Fortnite, there aren't enough buttons. I need extra buttons. But when children beat me in Fortnite, I get really mad. And I want to tell them that they have no life. Their parents will never love them. They will die alone. And they need to, just go away. Get out of my life, right? I need to tell the children that. So I could go open mic, but then when they kill me and I punch my desk and I scream and I yell and I get angry, then they'd have that over me, right? They would win the interaction. They would get the satisfaction of knowing that they're making me feel like shit, right? And I don't want that, right? So I want a push to talk button, and the controller I have, it can only remap its paddles to other buttons on the controller. Right, and so what I need a controller that lets me remap one of the paddles to like a button on my keyboard for push to talk. And so obviously the only solution here is to build my own controller from scratch, and that's how we ended up here. So this guy, we've got kind of like, a little bit of like a shell that's what kind of works. We've kind of like printed it out a few times, kind of like felt it out. It feels like okay, right? I'm kind of happy with the hardware of this thing a little bit. We have to get a PCB printed still. There's like a little bit of effort that needs to go into there, but we're kind of interspersing software development in here because this is a software channel overall, right? After all. So the brains of this controller are going to be powered by the Raspberry Pi Pico. It's like a common microcontroller. He's cheap, like $7 for like the board, but the actual brains, like the actual like CPU and all of its controllers and shit, that's only like $1. But you're paying like a lot of extra money for like the breakout board and stuff like that, whatever. So this thing needs to talk USB to my computer, so that when I press buttons, they do something. Sick. So we have kind of done a little bit of USB work. Yesterday, we are kind of dodging the use of using the Raspberry Pi Pico's SDK because, partially because we're masochists, but also partially because we want like a better understanding of the hardware and how everything is working under the hood, and maybe we don't want to like get confused by some of the abstractions they're using. That's a bad decision, but it's the one that we're making because, we don't have any goals of productivity around here. we don't ever actually need to finish anything. And so where we're at as of last stream was we managed to communicate with the USB controller that is living on the Raspberry Pi Pico, and we managed to like Wireshark a communication with our desktop when we plug it in, and we got to the point where the desktop plugs in and he goes like, oh, there's a guy plugged in, let me ask him who he is. So he might do something like say, hey sir, what are you? And then we respond with kind of just like some dummy data. We're like, hey, we are device 1234567 with, version 1.0, and like we're a USB device that speaks USB 2.1 type shit. We got a little bit stuck here because the communication was inconsistent, as well as we weren't responding like fast enough. And so I'm just going to give like a quick recap of the fix that we made for that in happy hour today, and then we'll kind of move on to trying to actually communicate with this thing in a way that makes sense. Get them to show up when we type LCUSB, get them to show up as like a thing that like a Linux driver could communicate with, right? That's kind of like the goal. So it turns out what we were doing at the end of last stream was we were following the anatomy of a USB transaction. So the idea here is that, there's some bytes on the wire. They go wiggle, 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 right? But these need to get like turned into something that's kind of like higher level that you can kind of think about, right? So like, what you could do if you were just doing like serial, you might like chunk this up into chunks of 8, right? Be like 8 bits is a byte, and then you just like show the letters. What they do is they kind of like try to structure this thing in a way that makes more sense for like USB controller hardware. So they pack this stuff into like what they call USB packets. Wow. Right? Packets. And the flow of like one packet transmission is my computer computer or USB host, he sends kind of like some metadata about what the packet is. They call it the token. Then if the token says, hey, sir, I want you to send me some data back, he'll send some data. And then the host will go, oh, got it. Ack. Right? And this is if it's like, this is for in, where because data is going into the computer. The other one is like an out transaction. So it's like the token, data, and then the device acts back, right? So this is one USB packet. One transmission of stuff. I maybe packet's the wrong word here. My understanding of this is one packet. Now where we got confused yesterday is there's this concept where you stitch packets together into like a transaction, I think they call it. Well, words don't matter here. Words have no meaning. But there's this thing called like a, what is it? It's like setup. Setup's not the right word. It's like a control transfer. So a control transfer, i.e. what they're doing when they say, sir, could you tell me what type of device you are? This is a control transfer. Right? And what they do is they send one out packet, this chunk, these three things, and this says like, give me device descriptor, give me DD, give me some DDs, you know? And then we were responding to this, right? And so we responded to the next in transfer with data of our descriptor, right? Descriptor. Then what we missed here though is that now the computer says out, ack, I got it, hooray, I sure got what you asked. I got it, we're good, we're fucking good, right? And what's confusing here is we have acks at both like the packet level and at like the transaction level, right? And so I didn't really understand that this was a thing that we had to handle. Right? Because there's another piece of this where at the end of like what we did last stream, we kind of only like handled input transfers. And it turns out that like this particular output transfer is special because the USB spec mandates that you always have to accept setup requests, which this is like out setup. And so like our USB controller hardware on the Pico was like eating up all this stuff and just putting it in a setup buffer. But we need to specifically tell the controller that we are ready to accept data, right? Because this output data is going to go into some buffer and we have to like consume that buffer sometimes, right? So if somebody were to send us two things in a row, we need to say, okay, we got the first one, USB hardware, just like hold on a sec. We need to like look at that before you accept the next one or else we'll miss it, right? And so we never did that. We never told the controller, sir, I am ready to accept more data. And so when the computer tried to ack, he tried to say, yo, I fucking got the shit. We just never sent the ack to the ack, right? We never sent this part because we weren't ready to receive the data. And so that's what was causing kind of like all of the inconsistencies and like slowdowns and stuff at the end of the last stream. We spent like 2 hours in happy hour today trying to figure that out. We finally got there. And so that's kind of like the starting place of today. The work that's been done in between streams is like basically just trying to ack the ack. We just ack the ack. Simple. All right. So I think that's all the, recapping and background we need to do. Let's just fucking move on into trying to, respond to whatever the fuck we're supposed to do. I don't really know what that is. But like the goal here is like we want to see when we type ls USB, we want our fucking guy in here. That's the goal. And so let's just kind of like look at what Wireshark is complaining about and or like kind of like inspect what is happening in like these transfers and just try to answer these things reasonably, right? So let's hit start on this thing and let's reboot our little device. And so we see like a bunch of stuff happening here. Let's give him a sec to like time out on some stuff and we'll kind of see, we'll kind of like move from there. Okay. So we see that he comes in. There's a lot of stuff communicating with like the USB hub that this guy's plugged into. We can kind of like skim most of that. But what's kind of like the most interesting here is here he's saying, okay, get device descriptor at endpoint 0. So when you first plug this thing in, he's got no address. He says, let me see what's going on here, right? We respond, and then he goes, okay, I will set your address. That's not really captured in this trace, but he sets the address to 84 now. He just kind of like picks like the next number that's available. And he says, like, are we like the same guy? I assume is what's going on here. So he gets the descriptor again. We respond immediately. He's happy. And then he starts sending this like get descriptor boss. I don't know what the fuck this is. No fucking idea. But we probably should say, yo, bitch, we don't support that. And I assume actually that what's happening here is he's deduced based off of some information that we sent in our device descriptor that this is a thing that we should support. And it's not. So I think that we should be a little bit careful here. Maybe the first thing we should do here is adjust the device descriptor to like be accurate to like what we are or what we are trying to be at the very least. So in here, probably class and subclass I assume are pretty important, right? What the fuck are we? And I guess maybe we just copy the devices from the like a real Xbox controller. That seems kind of reasonable. So if I like just plug in my Xbox controller again, let's just see what he responds with. I guess we do have to, you know, actually run the capture. If we gotta capture the stuff if we want to see the capture, you know. Okay, so let's hit stop here for a second, and let's just kind of see when he sends a device response. He says device class 0, subclass 0. Okay, that's interesting. He surprisingly actually, the majority of this stuff is kind of the same. It could be that the vendor product ID here are relevant, right? It could be that the Linux kernel is seeing a certain set of vendor product and using that to assume other stuff, right? It's possible, right? Because we don't see this like boss request that we were seeing on our guy. So let's just do the stupid thing and copy. Let's pretend that we're the same guys. 3537-1086, and let's see if that changes anything. 3537-1086. Boom. What the fuck is going on? What the fuck is going on? I gotta stop. But there's this kid that plays football blind in a video from like 10 years ago. Maybe more. And that shit always cracks me up. Okay, so he still is sending that boss baby. So let's maybe compare. Like, what's the difference between why do that? So I guess I'll just like copy this. Copying it as text probably makes more sense, but you're not my boss. You can't make me. So I'm gonna unplug replug. And what does this guy say? Okay, so this is, I think, the controller. It's actually really unclear. Let's restart, make sure that our program's not running at all, and then replug the controller. The real bad boy. Okay, so this guy, he's BCD USB 200. We are not, we are 210. That's probably stupid, like somebody pointed out. And then is everything else kind of the same though? BCD device. I think this is like the device version number, which I think doesn't really matter. I'm kind of interested in changing our USB version to 200. Fuck 210. We ain't geniuses around here. And it does seem like, I think that I'm not seeing that boss baby anymore. Yeah, right? We're seeing request, response, and then immediately device qualifier, which is like a thing that we can actually see in the spec probably, right? Probably? Device qualifier. So this is a descriptor with descriptor type 6. Yes, so this is a thing in the spec which we can now deal with. So I guess let's answer that. Let's answer that. Device qualifier. And I guess this is kind of more like, what the fuck is boss baby? Which is not really what it said, but it's, you know, I hear what I want to hear. And again, you guys can't stop me. So can we just like look for this in the spec? What the fuck is this thing? Device qualifier. Here we go. So this descriptor describes information about a high-speed capable device that would change if the device were operating at the other speed. For example, if the device is currently operating at full speed, the device qualifier returns information about how it would operate at high speed and vice versa. Okay, I think it's funny that full speed and high speed are different. I'm just gonna say it. I would think that the fullest speed is the highest speed, but you know, I get that that's not probably like the language evolved this way in some way, but I just think that's like it's like when you have like two products. You like a company has like two products and they release like the best version and like the really like the other like the super best version or whatever. Like you're just like, "Oh yeah, they're both like you're scared to say that anything's not the fucking best one, and so we'll just call them both the best with different words." Like fine. Fine, I get it, right? It's actually probably more they called it full speed before they figured out how to make it faster. Yeah, right? It's like probably something like that, right? It started with low speed, full speed, and high speed at a later. Yeah. I mean, I understand that these things happen for a reason. It's just kind of funny. Um, so do we have to answer this? If a full speed only device receives a get descriptor for device qualifier, it must respond with a request error. What if we just did that? Wait, I guess, if we don't want to make that decision right now, do we just say that it's like the same guy? Okay, maybe we would try to respond with an error first, and then we come back to it. How about that? How about that? And then we can just pick which one we are. You can even support high speed, 480 megabits per second. Great. Sick. That's not gonna fuck with me at all. Okay. So how do we respond with an error? That's probably the thing to figure out, huh? And it's probably a thing that we ask the controller to do for us. That would kind of be my guess. So I would also guess that we can respond with errors to any type of request, which would make me think that this is a thing that we say on like the buffer control, right? We have buffers corresponding to different types, or like each of the like places that we could talk to. And so I assume that that's where we would say, yo, we give the fuck up. We got stall? Huh, maybe not. There's also the endpoint control register. Interrupt on NAC, interrupt on stall. So this is kind of more like global information about this thing. We're kind of trying to do like a specific thing. There are error bits here in this register, but this is kind of like a status register. Interesting. I wonder if error is not like a defined thing here. You know? What if we ask the fucking idiot? This seems like the type of thing that he might be able to tell me. In the USB spec, it says, what does a request error mean here? Like, which packets are, like, where in the USB packet is this flagged, question mark? Wow, look at this guy. He even knows what we're talking about. That's a good sign. The specific error response is typically indicated by sending a stalled. Really? Stall is error? Stall sounds so much to me like ask later, bitch. Can we, like, confirm that? Stall. Interesting. Okay. That cannot be set or does not exist causes stall to be returned. Okay. I mean, it is saying that for other things. I don't know if I saw that exactly for this request, but I mean, he's not crazy for saying it, for suggesting it. Thanks, idiot. Good idiot. uh, so I guess we'll kind of just make our default behavior to send a stall. Right? Just like, I think, how do we want to do this? We have to be careful to set the available bit kind of after everything else. So I think we do like, let's zero out the control register. We'll set his stall value to 1, then set this guy to this value, and then set the available after to say, yo, controller, you're good to like work with this buffer. Sure. So let's see what happens if we do that. Probably some shit, dude. Surprisingly, nothing happened here. But I wonder if it's like the same shit where we have to like handle like an ACK. Right, there's like a 5-second delay here, 5-second delay here. So that's not really great. That's not really behaving the way I would like. I guess like what is happening in our whole block here? We're like, we got a setup request. I wonder if we're supposed to say PID 1 here and full. Like, I wonder if we have to set full and available even though we're stalling. To say like, okay, you can extend this shit. It's all there, but we're stalling. We should probably look at the rules about setting a stall in this guy. Stall. So yeah, this is in buffer control. Available and stall bits should be set after the other data in the buffer control register. I wonder if available shouldn't be set if stall is set. Like those might be like independent. Okay. Stall bits. Okay, on it, if stall is set in the buffer control register, then send a stall response and go back to idle. But we're kind of doing this after. Oh, I see. So here he's like, if stall is set, do this shit. If available and full bits are set, then move to that phase. So here, instead of setting available, we should set stall. And I think we're trying to set both, which is probably fucking confusing. So can we just do like stall is equal to 1 here? Or even just like, just this? Right, so we get like a descriptor request that we don't understand. Oh, and I guess this should actually be done here as well. But this isn't what we're hitting, I don't think. Because we would be hitting that breakpoint, which we're not. Okay. So, does this do something sane? Reset. Reset. No, like, he's still just kind of hanging out here. Which seems, suboptimal. Suboptimal. I would think that we want to be like, bitch, no, like, immediately. So there's kind of like 2 options here. One is that the stall is just like not doing what we want. And then the other option here is that, like, it's either like we're not sending a stall like we think we are on the controller, or sending a stall doesn't result in the behavior that we would like, right? And since they don't, like, in the spec, they're explicitly saying stall in some places and not others, then I'm a little bit, you know, a little bit 50-50 on that. Can we look at, like, the get descriptor request again? Get interface, get descriptor. Okay, this request returns the specified descriptor if the descriptor exists. And so, okay, what happens if it doesn't exist? Maybe we just return. Maybe we should send like a 0 length return in that case. Specifies the descriptor type in the high byte and the descriptor index in the low byte. Yep, descriptor index is used blah 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 to pick a thing. For example, we can, yeah, sure, I don't care. Range of values used is 0 to 1 less the number that we support. Sure. This field is like a language ID, which I don't really care about. None of this is like what I'm looking for. The standard request to a device supports 3 types of descriptors: device, also device qualifier, configuration, also other speed configuration, and speed. High-speed device supports this to return information about the device at the speed is not operating. True. Other speed configuration is the same, but for configuration. If there are additional interfaces, blah, blah, all devices must provide a device descriptor and at least one configuration. If the device does not support a requested descriptor, it responds with a request error. Can we look for like this word? Like that's like capitalized and shit. Request error. When a request is received by a device that is not defined for the device, then a request error exists. We deal with this by returning a stall in response to the next data stage transaction in the status stage of the message. Okay. It is preferred that the stall PID is returned at the next data stage as it avoids unnecessary activity. Okay, so that is what we were supposed to do. But then, maybe, we are not acting this thing correctly. That seems kind of possible and maybe even likely. So like, I would like to see what is the transaction flow when a stall is hit. USB control transfer stall. It's like it knows, dude. Picture? We love pictures, dude. I guess this Microsoft link has been kind of nice. Can we look for stall in here? Finally, the host completes the control transfer by initiating the last transaction. Yeah, so like the spec is saying like send a stall in the data phase. That's totally fine. He could have been the status phase, but like fuck it, whatever. And so it seems like it should be fine. I would like to try setting a stall in response to like something else. It might also be that we have to support that thing. Right? He's kind of saying like in the spec, it really implied that that was like a required thing. You know? The standard request to a device supports 3 types of descriptors, right? He's like device and this. So it's kind of like implied that we have to. I don't know if that's like true. So it could be that like even if we're stalling correctly, it might not work. But can we try setting like stall on here instead of available? Like in response to get descriptor, we're just like fuck you. Right? Like does that change anything? I mean, that does change things. He's definitely like it's stalling, right? Which seems kind of reasonable. Right? I would think that stalling is stalling. So it's hard to know. We don't have like any examples of a stall anywhere. So we can't really tell if this is like the expected behavior of that thing. You know? Stall. And if EP0 the appropriate Aha! Aha. Okay. So we just need to set this guy as well. He's saying, you gotta, bitch. So... what is this guy called? EP stall arm. I guess this is gonna get its own type. Sure. USB EP stall arm. And I guess we just have like a couple fields here. It's EP0 in at 0 and EP1 in at 1. Wow, or EP0 out at 1? Yeah. Because endpoint 0 is special. He has to exist. Okay. So now when we set the stall bit, we gotta stall with USB EP stall arm modify EP. We're stalling on in, I guess. All right. Restart this thing. Restart this thing. I mean, things are moving quicker. Yeah. Look at this. Look at this. Look at this. So we call get descriptor. We respond. He calls device qualifier. We immediately shut that shit down. We're like, fuck you. Right? And then configuration does the same. And we're kind of doing this for anything that we don't support right now. So that's kind of behaving, the way that we want, which is sick. So we're like, fuck you, no device qualifier. Then it looks like he tries to get configurations and we like fail that too. And he's just like, okay, then like shit's fucked. Is kind of what I'm seeing here. So let's try to respond to a get configuration request now. Kind of sanely. Yeah, let's do that. So configuration. I guess that's here. Get configuration. What do we fucking answer, dude? There's like somewhere that they're gonna like define the type, right? Probably protocol layer. Sounds like the place where this goes. Skimming. Well, where is like descriptor? So this is a 9.4. Let's actually like, maybe look at the chapters. Standard USB configuration here. This is it. Here we go. This is what I'm looking for. Device qualifier seems more likely to be required for LSUSB than config. No, based on nothing. I think that like every device is required to support one configuration at least because they're also like it doesn't know what to do. If I remember correctly, the thing in LSUSB is like tied to configuration, I think, in some way. But yeah, it does seem kind of interesting. We should just check. Oh, for a second I thought it was there, but that's just the Xbox controller. Like, I assume that we're not in here, yeah. I suspect that the fact also that it's continuing on to get configuration, my assumption here is that, like, we just tackle the last thing that happens, and eventually we'll get to the right spot. You know? And I guess we should be careful. I don't think this is get configuration. This is getting a descriptor for configuration, which I think might be different. Might be. But we can see. Okay, so I guess we just kind of yoinkies this shit. And in here, we have device descriptor somewhere. I guess we just define configuration descriptor. And this stuff is supposed to go low bits to high bits. And this copy paste kind of sucked. So I guess we'll just do B length 1 U1 B descriptor type. Wait, U1. This has got to be U8, right? It's got to be. We got W total length U8. I think it probably makes sense. U16, sorry. It probably makes sense to use the names in the spec directly. I think that actually kind of fits better than trying to like convert these into names that we like. I configuration U8. This is also U8. This is also U8. And then can we, like, if I do this, does that crash? I want, like, an assertion that, like, this is correct, that lives, like, that happens somewhere. And you can't just, like, do this in a struct, I guess. What if I do this? Or what, like, can we do this? That seems to, then I assume compiling, it doesn't even fail. God damn it. God damn it. Yeah, maybe you're right. Maybe I can just do like this. And then do like std debug assert false. Does that work? Nice. Nice. Good call. Good call. Configure, so we want like a bit size of configuration descriptor over 8 is equal to however big this thing's supposed to be. Is this just like not written down somewhere? That's annoying. This is 9 though, so there. Okay, cool. 1, 2, 3, 4, 5, 6, 7, 8, 9. I mean, that all lines up. So I guess we'll just kind of leave it like that for now. Okay, so if we get a get configuration, which this is starting to get hard to parse, so let's actually get those fucking names right. Descriptor types here. So can we just go like descriptor type is an enum. Boom, 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 boom. I guess those numbers are actually relevant. So is enum right here? I think it is. So let's do this. 1, 2, 3, 4, 5, 6, 7, 8. Okay. And then this has to be backed by a U8. And I guess we have to make this a non-exhaustive enum. Maybe we don't. Maybe we don't. And then let's do a lowercase and equals. Okay. And then I guess here we can take the value. Type descriptor type is std meta enum from or int to enum of value should write by 8 of USB descriptor type. And if this fails, I guess we like return an error. Which is like send USB error. Send EP0 stall, I guess, is kind of where we're kind of sitting here. Right? We kind of want to do this. And then here we're going to do like function send EP0 stall. Kind of does this. Right? There. Sick. Send EP0 install, I guess. We might get better names for this later, but this is fine. And now we can go switch on descriptor type. And this was device. And now we can do configuration. Breakpoint, just make sure this gets hit. And we should hit that breakpoint. No, he's mad because 928. Really? It's an error? Fine. And then this needs to, I guess, like, is this like a return? Surely not, right? Because we still need to get down here. So this is gonna be like setup rec, break, setup rec. Obviously, this should be like LOL functions, you know? But we'll put up with this for now. Okay. So we run this thing. We should see a breakpoint in the configuration section. Instead, we're getting... That's interesting. We're getting some sort of like angry at 880, which is just like here. The fuck? That's weird. Very interesting. The fuck? Very strange. What if we change this to unknown here? And then here we say catch unknown. And we do this. Stack misaligned or something? Yeah, I guess that's not out of the question. I wonder if like this label though, this like label break shit was causing some problems. No, that's still like really fucking shit up, dude. Yeah, I could also be like the alignment of the USB IRQ function has changed and maybe we are not handling that correctly, right? If this is not aligned right. Wait, that's Linux Mint, right? Or am I stupid? No. Linux Mint, you can't identify Linux Mint from looking at the computer. Yeah, I think that there might be like alignment requirements on this interrupt table functions. Like, I bet it's like something like if I move this function down, does it start working? That wouldn't shock me. No, actually, but we could actually, so this guy's at this address now. Can we go back in time to just kind of check the alignment of him before we did all this? We got to be careful not to lose too much progress, but undo. Okay, so here everything should be fine. I think it was working at this point. It did say do nothing. Yeah, true. B USB IRQ. B USB. Really? Oh, it's so annoying. Let's do this. Redo everything. Save main backup.zig. Okay. And then here, can we breakpoint here on the USB IRQ? And like, what address is that? It's the same address. Same address. So that kind of indicates to me that it's not like alignment issues of where the USB interrupt is. Because I'm pretty sure that's 1068. That looks like, at the very least, 68 was definitely the same. So copy main backup to source main. Right, and now we should have this guy falling over again. And it is 1068 again. So that's kind of interesting. My main final v6.zig. Yeah, that's some classic school shit, dude. Yeah, that's very strange. I guess we just have to bisect, since like we don't have any idea why it's fucking broken. We just have to bisect until it works, right? So before we were doing value shift right by 8 here, not using descriptor type. This said 1, right? And then this said else here. Does that work? Interesting. Oh, I wonder if like this int from enum shit, int to enum, is it possible this thing's panicking instead of just like kind of failing nicely? 0's not an option in here. Oh, but we're not, we should never be at 0, right? So can we just do like, just call this function discard the answer? Does that start causing problems? Yes. Interesting. That's interesting. The fuck? Very interesting. Very interesting. Can we, is it like something fucked up with the binary? Readelf? No, nothing obviously fucked in there. I would love to see like more resolution on this failure. Right, like we're just seeing like signal handler called in the USB IRQ. It says at 875, which is like right at the start, right? So we don't really see like exactly what line we fucked up on, but we do know it's in here. So I guess like we could start doing like some crazy shit. Like we could copy paste this shit here. And, you know, see if that still fails. It should. Yep. And then we can start like bisecting this. Return an error unconditionally. Right? Just like, or I guess it's easier to do it this way. You, if false, then you don't have to fucking deal with unused variables and stuff. We just return an error. Does that fuck everything up? Interesting. So if we're like, return device. The fuck? So just returning an error at all is just like fucking us up? That's interesting. So maybe Zig is doing some like funky shit with errors, and we are not like handling that properly, and however we're doing our like program setup, right? It seems quite likely that that's the case. So let's just change this for now to return null. And I assume that fixes it. $951. Right, like I assume that fixes it. Yeah. So that's at least working. We can do descriptor type. Switch on descriptor type. This is device, and this is else. So this should all still work. Fuck you. Unknown. Yeah, okay, that's interesting. We're gonna have to come back to this for sure. But I don't want to solve this right now, so I'm just not going to. Easy fix. So errors don't work. But we gotta focus. So now we go back here. We should breakpoint on configurations. Right, we should see him like that should be a thing that shows up. Hype. And now we can try to send the appropriate response. Now we should probably also start like abstracting away all of this shit a little bit, like the dispatch send on endpoint 0. This is probably EP0 in buff, huh? Probably. Let's double check. So I think that in and out are not shared, and I think we were stupid for thinking that they were. So where is the data used here? We were putting some data in a buffer for the controller to send. Where's that shit go? Control. Oh, maybe in and out do share. They might. Okay. Okay, so here let's pull out all this stuff that's we have some stuff and we want to send it. That's kind of all of this should go into one function that's send EP0 data or something. We can stay specific for now. Respond EP0 in. For now, that's fine. This will get refactored later, but whatever. And then data here is some slice of shit. We mem set the thing with 0, and then I guess we set it up to dataLen here with the data, right? And then everything else here is now EP respond EP0 in with this. And then all of this goes away. And now we can easily kind of replace this with the configuration request with a configuration descriptor. Length here has to be, I think it was 9, right? I think. Okay, and then I guess we just fill them in as we need. Okay. Cool. So what is our configuration descriptor type? I don't fucking know, man. Device qualifier type. Wait, that's qualifier. My bad. Configuration descriptor type. Does it not tell me where those are? Configuration. Configuration descriptor type. Really? It was just a constant? Oh, I see. Right. We're telling because it casts the structure. So here this is supposed to be equals configuration, right? Right. Because these are just kind of generic descriptors. And so when it first gets this, it needs to know how to what it's casting to. I guess we are going to have 0 interfaces. We'll see if that's valid. Configuration value is to use an argument to set configuration to select this configuration. So 1, I guess. I configuration is what? Index of the string configuration. So I guess we're gonna have to make a string table at some point with unique IDs for everything. So we should probably start setting that up now, I guess. USB string table. Right? And I guess this thing is going to be an array that's of the length of USB string table index. is like, you know, we're gonna have like all of the things that they might need to talk about, right? So manufacturer, product, serial number. Manufacturer, product, serial number, right? And then what was the next thing? Configuration name or something? So this is gonna be like can we get like the number of items in an enum easily? Uh there are a few things I despise, but signing to Twitch is one of them. Horrible. Yeah, hell yeah, dude. So manufacturer is gonna be Sphero, Foria, Chicken, Run. What is like the fucking string on this like Xbox controller that looked like so fucking stupid? Chicken Run, Network Technology Co. Yeah, dude, this is just like so fucking funny. So we are the Spheriphoria, Chicken Run. What else? This fucking dumbass shit. Network code. Network code. Uh, use run stop technology. Like what else? What else are we shoving in this shit? Co LTD. Like what are the other options here? Inc. Incorporated. Controller for Xbox, computer, gaming for children or something, right? Just like something like fucking stupid. I guess half of this is the product. So this is the manufacturer, this is the product. And I guess this shouldn't be a string table right like this, right? This should be like actually more like strings. USB. Sounds like one of those Spider-Man Elsa YouTube videos. Hell yeah, dude. Because we don't actually need to store these in a table in like an array. That's kind of more for them, right? So manufacturer is this. That's better, yeah. And then when they look up by string, it's easy for us to like just, you know, return something. And then probably we can get fancy. And like if since these names match, we can do some sort of like bullshit Zig meta shit. Okay. Okay, so that kind of solves that. So now these guys' products are gonna be like int from enum. Everywhere we're gonna do like USB. What do we even call that shit? Oh. USB string index, we call it here. Int from enum USB string index dot product. Here we go. Hell yeah, dude. Okay, that's better. So now I configuration can be int from enum of USB string index dot configuration name. Boom. A string can't be longer than 255 bytes. The encoding is UTF-16 LE, so 128 characters. Okay, we'll make sure to maximize that later. For now, for now it doesn't matter because we're not actually returning it, and I'm sure that this will come back up when we actually have to. But good eye, good eye. So what's going on here? Attributes. Reserved, reset to 0, remote wake up, self-powered, reserved, set to 1. So we just set D7, we just want D7 to 1 and everything else 0. 1, 2, 3, 4, 5, 6, 7, 8, and we'll go fix me better type here. But we're just gonna copy paste this. Ugh. All right, there we go. Okay, and then B max power here. I don't know, man. I guess we'll have to measure this. I guess we'll just write 50 and then call it a day. Fix me, uh, power, like, actually pick a reasonable power consumption, right? Cool. Oh, I see. This needs to have. He needs to know the type here. USB. Uh, where is this thing called? Descriptor type. Yeah, I guess. Okay, cool. And can we look at Wireshark and see what's going on? Run. So get descriptor response. Hello? Where's all the cool shit? Why am I not seeing like get configuration and shit? Restart. Run. Run. Like surely one of the like I'm seeing a lot of talking with the hub, not a lot of talking with the device. Like maybe zero talking with the device? Why is this different? Like I'm not even seeing the get device request. Oh, get descriptor here. So this thing does respond. Then like we don't see the rest though, which is kind of interesting. Is that because we're answering this? Like if we're just like if false, do this. Otherwise send EP0 stall. Like does it go back to kind of working the way we expect it to? Run. No. What the fuck changed? Are we like accidentally stalling the response here every time or something? Like is the stall bit getting like stuck or something? Because I feel like we haven't really changed much. I guess it's like respond EP0 in shit. This transfer length is kind of wrong. But that shouldn't really matter. But I guess it's like an option for why this is fucking broken. But again, like he's responding fine. Immediately, right? This is great. Then like I'm gonna full reset the board because sometimes that changes stuff. Oh yeah, here we go. Yeah, I don't know. We'll just shut up. Shut up, shut up, just shut up, shut up. What song is that? Shut up, just shut up, shut up. Black Eyed Peas. Yeah, a real classic. A real classic. Okay. So here right, now he's back to asking for the configuration and us not answering like we expected. So if true here now. And now we're at 1025. So here he's asked for something that again we don't know what the fuck to do with. Set configuration. Ah, and nice. Here he's asking for those strings that we're not answering, right? So let's I bet you if we send these strings back, that's like the stuff that he needs to put in LSUSB. So that's kind of exciting. Let's try to, and then here he's using string indexes probably. Let's try to answer that. Let's try to answer that. String. So that means that we need to actually get like whatever the fuck a string response is supposed to look like, which is fine. So we need to get to the USB stack probably to get that shit. So we have like configuration, strings here. String descriptors are optional. All references to string descriptors in the device configuration and interface descriptors are reset to 0. I want to support them. That's the funny part. So string descriptors are Unicode, this thing. The strings, the USB may support multiple languages, blah, 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 lang ID. So here, if they ask for offset 0, we're supposed to return the size of the descriptor, i.e. how many strings we have, essentially. N plus 2, yep. Then the type of this thing is is string, constant. And then each of these guys is just like the thing. So if he's looking for index 3, he's probably looking for like index 1 in this table or something. Right? Probably something like that. And each of these are like a number. A number. The fuck? Okay, wait, hold on. The array of lang ID codes. Okay, string descriptors use Unicode encodings, blah, blah, blah. The list of currently defined lang IDs can be found here. String index 0 for all languages returns a string descriptor that contains an array of 2-byte lang IDs. I see. So if they ask for string index 0, we return this thing instead of the string. Otherwise, we return this, which makes way more sense. Way more sense. Okay. So if we get string, we look at which index they asked for, or the index. It must be. Right? Index 0. It's got to be index. It's got to be, because that's also what we're seeing here, is it's going in the length 2 here is interesting. So it's just going like get descriptor index 0, length 255. Oh, right, okay. So this is the lang ID table. And we'll just return, maybe we just return that we don't support that still. So he tries that 3 times. Then again, descriptor index 0. Oh, but 0 is reserved, and we used 0, which isn't allowed. So here, well, this has to be equals 1. To get everything offset. That might change the behavior here, so that he asks for the big boy table first. Then we reject that a few times. And then we kind of fucked that up because we accidentally copy pasted here, and we weren't done. So let's go back to stalling here. Okay. So now he's trying to get string index 0 for that lang table. We say fuck off. No, he's still using 0 a bunch. Language ID, no language specified. So I guess maybe we will just return no language supported. So if index is equal to 0, I guess we return. I guess we need like configure wherever this configuration descriptor is defined. We can define this as like lang table descriptor. And this is kind of interesting because it's kind of like a dynamic thing. I almost want to just be like 2 and descriptor type string. Like just have no language supported and then respond with that. That doesn't seem that crazy. Let's see what happens if we do that. Yeah, like this. And then I'm worried about like padding and stuff, so let's just do this. Else we stall. Okay, let's see what happens if we do this. The fuck? 1058? What is this? This is if the request is something different. Oh, I see. For the configuration request, which we're not handling yet. Okay, cool. So we run it. Here, now he's sending a bunch of string requests. So he finds string 0. Now he's sending our other guys, which we're still rejecting. Okay. Cool. So now we can start sending the other guys. So we do like a int to enum of USB dot. Where do we set our string table? USB string index from index, or else unknown. Okay. S is this, or index, I guess. And then we can do like a inline switch index. If it's unknown, send EP0 stall. Else, we can do one of these like Zig generate me a fuck ton of different switch statements for like the tag name. And then in this case, we're going to have like S, the string itself is, fields on USB strings of T or something. Is this like a thing we can do? Field. Yeah, seems fine. He doesn't like that though. Expected type constitute found USB string index. Oh, do we do like, how do you do this again? Inline else in Zig does it not return me the name? Or maybe it's tag name here? Yeah, that sounds right. There we go. So now we have the string, and we just return it in this thing. String descriptor. And then I guess I don't really know. We have to like construct this thing, so I guess it's kind of more like, we pack this thing into a U8 byte slice from buffer, I guess. And we're like, buff 0 is equal to length. Buff 1 is this. Then we have like the string. Right? And we see like memcopy buff 2 onwards to like 2 plus slen from s. And then length here is slen plus 2, I guess. And then return buff 0 to slen plus 2, I guess. Right? Sure. Sure. So we're like string, we have like buff is like this. Then we pack this thing into buff. And we want to pack the string s. And then we respond EP0 in with 2%. Yeah. Hype. I think that's right. Int cast here. Okay. And what the fuck happened? So why are we responding nothing here? Seems kind of bad. We're like descriptor index 1 and our response is just jack shit. Why? I feel like we need to breakpoint here. It feels like it's not working. Unless it's always unknown. I don't think that's the case. Okay, list. Oh, interesting. Maybe it is always unknown. Oh, that's weird. So we're just never hitting this case? Any of these? The fuck? If index is 0, otherwise, okay. Yeah, zig build, run this thing. Are we ever hitting the case where it's not 0? Yes. Okay. Index is unknown. Why? Index 1033. Because I'm a dumbass. No? That's confusing. 1033. Are we confused about what the fields are on like get descriptor? Yes. Yes, we are. Yes, we are. So we want the descriptor index is actually value in 6ff. All right, let's see what happens now. Does that make more sense? Yes. Yes, that makes more sense. Okay, let's see if that works. Not looking super good here, huh? Okay, so I want to restart this thing, hit run. Let's just try to like, okay, so here he calls get descriptor 0. We go jack shit. He goes, okay, let's try to get string 2. And we go, here you go, bitch. And this data looks right, but the content here looks wrong. So I think that somebody said, yeah, it doesn't support UTF-8. It's supposed to be UTF-16. That sounds definitely familiar. That definitely... so do they say that in here? Unicode encodings, worldwide character encoding version 3. So I'm assuming that's UTF-16. That's what you're saying. UTF-16 LE specifically. Okay. I believe you, and we'll kind of see what happens there. So when we pack string here, I guess here we need to convert this thing. So stood, there's gotta be some sort of like UTF-16 in here. Zig's gotta have UTF-16. It's gotta. Unicode, yeah, Unicode. Format UTF-16 LE. No, we want to convert to UTF-16 LE. UTF-8 to UTF-16 LE. Yeah. Yeah. Which returns an error, which we don't know how to handle right now, which is going to be annoying. But we can just hope for the best. Because I think if the error doesn't trigger, then it's fine. I think. We'll see, though. So we can kind of just do this, right? And this becomes 2 plus size now. And this is like this. Let me see this. I think so. Increases pointer alignment. What if we just say fuck you and hope for the best? Alright, let's see what happens now. Fuck. We are panicking in here. Probably because that align cast is no bueno. Okay, so we need to force this thing to be like aligned by 2. Then this align cast doesn't do anything. And then here, can we force buff alignment? Like this? No, I can't. What if we just say U16s? This is annoying. It also shouldn't be null terminated. I don't know how Zig deals with strings. Yeah, I think it's fine. We are frame 5 now. So data len is too big now, which makes sense. So we need to make sure that, I guess this is the wrong length as well. Which should make it now that it crashes on the UTF-8 pack. Yep. And so now here we just have to make sure that we go like S from, I guess we just have to pick shorter strings. So let's get rid of these jokes for now. Just to kind of reduce the chance of like that overflow. Um, 1077, right. Okay, so that means that this probably happened, right? So now we got spheriphory. Okay. 1111. I don't know if it doesn't like something at the end here. He's kind of like fucking up the last character, which seems kind of bad. I guess maybe the size here is like the wrong value. Returns index of next character. If exact fit, returned index equals to output slice length. So this probably has to be times 2. Right? And then we are at frame 2 again. Right, this thing is returning. Yeah, I think so. And then our, like, these guys are... Oh, surely not. Everything's shorter. Yeah, surely this is a mistake somewhere. This must be this size times 2. That must not be right. But I don't know why it wouldn't be right. No, he's still mad. Whoa, what's he mad about? What's he mad about? Let's go back to here. Okay, wait, is that better? So yeah, we're seeing spinning sphere instead of spheriphoria, right? So obviously something is fucking stupid here. To send, here he's yellow because length must be even. Right, so that kind of lines up with this being times 2 here, right? Okay, controller, spheriphoria, 111. Okay, so he's happy actually. This is all great. This is all great. So we can go back. I think that those strings are coming in now, right? We have spheriphoria, we have string 1111, we got controller. Is that like the strings that we're trying to send? Spheriphoria, controller 1111. Yeah, I think we're chilling. I think we're chilling. Which should mean that we can go back. So strings looking pretty good. And now he's mad at set configuration not working. And I think that's the last thing we have to support, probably. So set configuration is 9. So I think we just write like 9 here. And we write breakpoint. It should be like, we should breakpoint here. We should. So we're at 1057. That is this. Okay. Fix me. This should be, request should be typed. Okay. But now we're in like the set configuration request. And do we have to do anything? Or do we just say, okay, because we only have one configuration? If we only have one, we might not have to do shit. So set configuration, baby. Lower byte is this thing. Configuration must be zero matching configuration value. If the configuration value is 0, the device is placed in its address state. Upper byte of W value field is reserved. Okay, so let's just assert that it's not 0. B configuration value is 1. So yeah, we just assert that value is 1. And then do we have to do anything? Surely we have to like answer, right? Surely we have to send like EP0 out act or something, right? Surely. Which is gonna look a lot like this, probably. Let's look at like the RP2040. When we're in device mode and we're working with the controller, we're device mode out. So when an out token is received from the host, the request is handled as follows. We do the token phase. Okay. Is the available bit and the full bit unset? If so, go to the data phase. Unless the stall bit is set, in which case the device controller will reply with stall. Okay. So we're kind of like getting here. I guess here, once we get a request for set configuration, I actually don't know if this is in or out. What do we respond here? What do we respond here? So are they trying to ask us for anything? No, they're just trying to give us some data. Which means that like we probably just have to respond with an ACK. So we probably take like our out buffer and just say we're like ready to fucking go. It might just be exactly this. EP0 finished. Out finished. So, okay, let's go back. Okay, so store data in buffer, otherwise go to ACK. And so maybe he just like immediately acts. So like, is this maybe just like fine? Maybe it is. Maybe we don't even have to do anything special here. Maybe the controller just does everything for us. And I wonder if we just ls USB here, if like our thing exists. He's crashing on UART write on pack again on the string descriptors. Why? Didn't we fix this? I thought we fixed all this. Because he got... Did he not get what he needs? He got controller. He got Spheriphoria. Huh. The fuck? I'm confused. Run it again. Oh, you know what? I bet you this actually worked up to here, and then when we typed LSUSB over here, that doesn't know we're fine. Let's go! Let's fucking go, baby! That's fucking sick! Let's fucking go, baby! I wonder if this is like inconsistent in some way. Right? It seems like running it a second time, we're hitting some like problems in our like string packing. So we're doing something fucking stupid in here that's like causing problems. But it seems like it works sometimes, which is kind of worse, to be honest. So here, everything worked. They called set configuration. it feels like we're not answering this thing. But it also feels like at this point we should have dev bus 98 ready to go. Which does exist, and we type OSUSB. We're definitely there again. So I don't know what like the problem is there, where sometimes he seems to get a little upset. Because this is seemingly working. So that's pretty sick. Pretty fucking sick. That means like we're probably in a state where we can start trying to talk to this guy soon. Right? But I think this is a pretty good spot to call it. I guess, you know what we should do though? We gotta bring back the chicken run. Chicken Run, LTD, Co. Inc. Incorporated controller for children, children and adults anywhere who want to. Like, I guess we're a little limited on space, so we gotta be a little careful. Right. So here we probably respond EP0 in, yeah. So let's just auto truncate this thing, I guess. We'll take like the const data len is the minimum of data len and 64. That will fix this for now. No, wait, hold on. Oh, is it because our EP0 buffer is shorter than the 255 byte buffer? It is. So if we went and have to like double buffer or something, we're probably limited more by like our internal. Your string can be 255 bytes? Yeah, but like our string can't be, I think. We're kind of back to this packing being a problem. I don't know what the fuck is going on there. I wonder if this is like an alignment thing. Oh, oops. My bad. My bad. The mem copy links have to be equal. All right. So he's stuck? Are we crashing? Yeah, why? There's something wrong here with like the way that this pack thing is called. It like works sometimes, it doesn't other times. Oh, maybe now it's that the strings are too long or something. Yeah, I don't know. Let's do this. Let's not get crazy. Still, huh? Alright. Spheriphoria. Controller. These values worked. I don't know why. Even now, why is it like this, man? We are doing a bunch of like bullshit. Okay, so let's take in like U16. Can we UTF-8 to U16 without it going into a U16 buffer? UTF... Like, is there like UTF-16... Yeah, I guess it could also be like invalid. It's surely not invalid UTF-8 ever. That shouldn't be happening. So it's gotta be more like this pointer cast failing. That seems kind of possible. So if we take this thing in as a buffer of U16, like a slice of U16, and then kind of do like this. And then do buff U8 is a U8 slice. Then do this like this. Surely that's okay. Still, he's still mad. And it just sucks that we can't see, like, exactly where. I guess this doesn't have to be pointer cast here. So now, what if we just don't put anything in here? I assume that this is okay. If we just return with empty strings always. If that still crashes, then we're very confused. Yeah, okay. So now we're just returning empty no matter what. Okay. And so it's definitely this thing is freaking out. Ugh. Ugh. Okay, I think that like we just have to figure out why we're panicking if things error, because that'll make it way easier to debug. So I think we call it there. It would be nice to be able to like get it to the point where it was working again. But I don't really know what changed there. Other than like alignment stuff. Right, unplug, replug. Sometimes that just changes behavior, which is super cool. Love that. Nah. So then it would be like, if it was like alignment stuff, then if we just undid enough times and got to the point where it was just kind of working, maybe then we're chilling. Yeah, that's some classic alignment problems, dude. Okay, so we're back here. This guy's showing up. It is what it is. We'll figure it out later. I'm gonna try to like look into the errors a little better, probably for the next stream. But this is exciting stuff. Exciting stuff. We got our name. Our name is here. Look at us go, dude. Thanks for watching, guys. If you like what we saw, we stream most days. We aim for around 12:30 to 4 Pacific time. It is 4:30 now, so if you're watching live, anywhere between 4 hours ago and now is when you should expect to see us. We are working on this Xbox controller. We will probably be working on this Xbox controller for the foreseeable future. There's a lot of stuff to cover. There's like, you know, firmware, hardware, PCB design, like configuration software on the host, drivers that we can like talk to programs and stuff. So lots to do, lots of fun to be had. Swing back by if you're interested. If not, no big dealio. If you want this content to continue, please consider supporting on YouTube, Twitch, or Patreon. What you get in return is access to VODs that we don't post to the main YouTube. So sometimes there's just stuff that's like, it's small, it's side questy, it's not algorithm friendly, and so that stuff I don't post. But it will end up over there. So if you want the stream to continue, it will die when I run out of money. But, you know, that's fine if that happens. But if you want to extend the lifetime of this by some amount, you can contribute where it makes sense. That's all the plugin I want to do. YouTube, peace out, and Twitch, let's find someone to raid.